Welcome to my science tutorial, and in this video we are continuing with our series of teaching on aromaticity, and today we are looking at counting of pi electrons. Counting of pi electrons, it is very important in determining whether an organic compound is aromatic or non-aromatic. So in your exams you're going to be given a series of compounds and you'll be asked to determine which one is aromatic, anti-aromatic or non-aromatic. And then in our previous video we did mention that there are some things we look out for when we are talking about aromatic compounds. And then the first one we look at was cyclic ring. We check if the compound is cyclic, and then we also check for complete conjugation. And then we also look out for resonance. And then we also look at Haeckel's rule. So this is 3 and this is 4. Haeckel's rule. Alright, so when we were talking about Haeckel's rule, we did lay emphasis on some numbers because we said for aromatic compounds they have 4n plus 2 pi electrons. So we said that if we have our n to be equal to 0, 1, 2, 3, or we have these integers and more, that it means that we're going to be having 2, 6, 10, 14, 18, 22, and a lot more. We're going to be having these numbers of pi electrons in different compounds that are going to be aromatic. So if you are given a compound and you count the number of pi electrons in there and you have heat to be equal to any of these, that we can conclude that that compound is aromatic. But then we did say that for anti-aromatics, anti-aromatics, we said they have their pi electrons to be equal to 4, 8, 12, 16, 20, and we're going to have a lot more because we said using Haeckel's rule they have 4 n pi electrons in there. So if we take the integers, these are the numbers we're going to be having. These are the numbers we're going to be having for 1, 2, 3, 4, 5, and a lot more. So anytime we take a compound we have this number of pi electrons in there, then probably that compound is an aromatic, is an anti-aromatic compound. But if we're talking about odd numbers like 3, 5, 7, 9, 11, odd numbers of pi electrons present in the compound, that is telling us that that compound probably is non-aromatic compound. And then once it's non-aromatic compound, it's not going to have any of these properties. It can be cyclic, but it's not going to be conjugated, and there's going to be poor resonance in there. Alright, then there is one thing that we have to take note for, and that thing is rehybridization. But before then let's look at this. If we have this let's look at these compounds here. And then we have this. Okay, just double bond. Alright then, before we look at this, we have to, let me just echo this, we have to take note that our pi electrons usually occupy p orbitals, because you know that pi bonds are formed if we have p orbitals. We have p orbitals overlapping. We have p orbitals overlapping with each other. That is how we form pi bonds. So our pi electrons are found in p orbitals, and also we in an sp2 hybridized carbon atom may contain 0, 1, 2 or more pi electrons in its p orbital. And so let's look at this. If you look at this, probably there is an empty p orbital here which has no electron there, so we can say that we have 0 pi electrons in this compound over here. But over here we found out that there's a single electron. There's a single electron in the p orbital here, so we have 1 pi electrons present there. And over here we have 2 pi electrons. 2 pi electrons in the p orbital. 2 pi electrons. Here we have 2 pi electrons as well. Two pi electrons. Alright, 2 pi electrons. Now, what do we mean by rehybridization? You might have some, just take a minute. You can have some functional groups like amide. So there's an amide, let's have NH2 here. Then we have a double bond O. So amide here, probably we might be expecting it to be sp3 orbital hybridized. sp3 hybridized. But the fact is, nitrogen here is not sp3 hybridized but sp2 hybridized. And then there is other functional groups. We can also talk about ester. We can also talk about esters. The oxygen here, probably we might be expecting it to be sp3, but it is actually sp2 hybridized. And then we have a lot more. We can have this. And this also sp2 hybridized. sp2 hybridized. So when we expecting this to be sp2 hybridized, then it means that it's going to have some kind of tetrahedral shape, but then we find out that these functional groups are usually trigonal planar because they are sp2 hybridized. But then what is actually happening there? What that means is that we have the lone pairs that is usually adjacent to the pi bonds, usually adjacent to the pi system. We have them to be in an hybridized p orbitals, and they are not really in the hybridized orbitals, so we find them in the empty p orbitals. Alright, now let's look at some some few examples and then look at how we can count the pi electrons in there and tell whether it is aromatic or non-aromatic or anti-aromatic. Alright, so let's look at this. We have this compound, a 5-membered ring. Alright, so we have this 5-membered ring, and if you look at the pi bonds, this is telling us that we have what 4 pi electrons in there. 4 pi electrons in there, but then there is something there. This carbon has a hydrogen here as well as a hydrogen here, and this is telling us that this particular carbon over here is sp3 hybridized. So we can only say that this compound over here is non-aromatic. Non-aromatic. What about this? Seven the pi bonds in there. So if you look at that, we can say that there is we can say we have 5 pi orbitals in there, because over here there is a positive charge, which means there is an empty orbital there. So if we count the number of pi electrons we have there, we have 2 here and 2 here, so this is 4 pi electrons. What about conjugation? If you look at this, we can see that this is kind of conjugated, because if we have this double bond to come here, if we have this double bond to come here, it means that we're going to have a positive charge here, and so we can find out that this compound here is fully conjugated. But then because we have 4 pi electrons in there, we say that it is anti-aromatic. It is anti-aromatic. All right. What about having the same compound, but then this time we have we have 2 electrons here, and then it is negatively charged. If we look at this, we can see that this is fully conjugated, because we can have this resonating all around. We can have this combining to form a pi bond here, and this will break. It will break to come to this side, as well as this breaking to this side. So it is conjugated. It is cyclic as well. It is cyclic, and then it contains 6 pi electrons. Sorry, contains 6 pi electrons in there. And like I said, it is fully conjugated, cyclic. 6 pi electrons in there, and this is telling us that this compound right here is what? Aromatic, because it obeys Haeckel's rule of what? 4n plus 2 pi electrons. 4n plus 2 pi electrons. All right, let's look at something else. let's look at a compound that is more complicated than this, one. Okay, let's look at cycloheptyl trienal species. So pick this here. Alright, so we have hept. So we know it's 7-membered ring. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Oh, there's something wrong there. Let's clean that and redraw it. So we have you can erase that. So let's redraw that, and then make sure it is 7-membered. So we have so let's count again. 1, 2, 3, 4, 5, 6, 7. Alright, that is it. So we have this here, and a positive charge up here, and then let's draw the same thing here. We have this, and then this time we have an electron up there. We have the same thing here. And this time around we have a pair of electron there, so we have a negative charge up here. Alright, can we tell whether this is aromatic or anti-aromatic or non-aromatic by counting the pi electrons in there? So if we take the first one, we have 6 pi electrons, 6 pi electrons in there. There is a pi bond, a pi bond, a pi bond. I will know that in each pi bond we have two electrons there. So 2, 4, 6, that is 6 pi electron. And then remember, this orbital right here is empty, which means that we can have this resonating. If we have this breaking to this side, then it's going to leave this place positively charged. And so it is fully resonating. It is resonating and fully conjugated. So once we have 6 pi electron there, it is conjugated, and then there is resonance. And what else do we have there? It is cyclic, of course, cyclic. So we can conclude that it is also therefore aromatic by Haeckel's rule of 4n plus 2 pi electron. Now let's look at this. We have how many pi electron here? We have 1 here. Remember, there's a pi bond here, so we have the first pi bond here, second pi bond, and 1 electron in this p orbital. So if we count this, we're going to have 2, 4, 6, and 7. So we have 7 pi electrons, 7 pi electrons, which is automatically telling us that this compound is what, non-aromatic. What about this? What about this one? We have 2, 4, 6, and 8 pi electrons. 8 pi electrons in there. That means it's obeying 4n pi electron rule, which is automatically telling us that it is what, anti-aromatic. It is anti-aromatic. Alright then. So that is how we count pi electrons, and that is how we count pi electrons in organic molecules to find out whether it is aromatic, anti-aromatic, and I hope this video comes handy and helpful in your examination. Now let's remember to subscribe to this channel and also share the link with your colleagues. Watch out for the next tutorial on aromaticity. Thank you so much.